So now we get to section B. The first question is question 8. So a function f has a derivative f prime x that is equal to 3x squared plus 18x. The graph of f has an x-intercept that is at x is equal to -1. Now we have to find fx. So how can we find that? The given is the f prime x, so we have to integrate it one time. So we have to do the reverse of the differentiation. So enlarge it, and now we know that the f prime x that is equal to 3x squared plus 18x, and now we have to integrate it one time. Right, so now we integrate it. Dx. So the first part will be equal to 3x cubed over 3, and then 18x squared over 2, and then plus c, and c is just a constant, just in the real number region. So we simplified the function. So that is the answer. And oh no, we can do more thing because we have the x-intercept. At x is equal to 1. So we put the 1 into the function. So when f1 we have 1 cubed, and then 9 1 squared plus c, that is equal to 0. So we can find that c would be equal to, okay, it should be -1, sorry. There should be -1. -1 cubed, -1. So we can get it to be 8. -8. Yeah, so the function would be equal to x cubed plus 9x squared minus 8. So that is for part A. For part B, it is asking the graph of f has a point of the inflection that at x is equal to p. So for the point of inflection, so what is point of the inflection? Do you know about that? What is point of the inflection? I think I need to have a next page to have a further elaboration. So now we have to deal with the concavativity. So now we have two curves. That's called concave up. Another one is concave down. So that is concave up. Another one is concave down. And we know that the slope is changing. That is negative, 0, positive. On the other side is that is positive, that is 0, that is negative. I'm talking about the slope. So we can see that the slope for the concave of that the slope is increasing, right? But for this one, concave down, the slope is decreasing. So we know that the slope of the slope is increasing, right? And the slope of the slope on the other side is decreasing. So that is the f double prime x is increasing. On the other hand, f double prime x is decreasing. So we can know that when f prime x is increasing, so we have f double prime x is positive. So when f prime x is decreasing, So we have f double prime x is negative. But now it's asking about the point of the inflection. So how can we find the point of the inflection? How can we find that? So now we have a curve. Its sinusoidal curve is like that. So we note that is positive, the slope is 0. Here the slope is negative. The slope here is negative, slope here is 0, slope here is positive. Right, we have all this value. So this asking about we can see that this from up to down, this from concave up to concave down. That's concave up, that's concave down. So we have up to down. It means that we have change in slope. Slope change. So we have delta slope. So we have point of inflection. But where is the point of inflection? That is here. So that is the point of inflection. Why? Because we have this one is the f double prime x is negative, and then here we have f double prime x that is positive. So we have the concave of move to concave down from negative slope of slope to the positive slope of slope. So it is to experience the slope to be 0. So there should be a point that f double prime is equal to 0, and then you move to f double prime to be positive. So you have a shift in the sign. So you have shift the sign, shift up the sign. So that is why we have point of inflection in here. So now we can do part B after this elaboration. For part B, so we have to find the double prime. So we have to differentiate the function one more time. So we have 6x plus 18, and then we have to put it to be 0. So we can find value to be 0 is when x is equal to -3. So that is the point of the inflection. And then we can find another approach to do this question, because the graph should be look like this, right? It's quite symmetric. This graph is symmetric. So you can think about that. There is a point. It's called P. It's like a symmetric axis of symmetry. So we have P that is negative 2b, negative b over 2a, and then we know b, which is just negative 18, and over 2, and then put the 3 inside, and then find it to be -3, right? So that is a, that is b, right? So that is how we can find -3. That is another approach. So I put an or here, and then for part C, so this is to find the values of x when it is concave down. So when it's concave down, the graph look like this. That is positive, 0, negative. So it's have to change the slope. So f double prime x to be negative. So it has to be negative. It means that 6x plus 18, that has to be negative. So we have find x has to be smaller than -3, so we have to check it. So check it. How can we check it? So we find double f double prime 2 and -2 to see what is the value in it. Plus 18, that is 6, which is greater than 0. How about on the left hand side of -3? So we choose -4. That is -6. So it means that we have, when x is equal to -4, we have f double prime that is more than 0, and when x is equal to -3, we have f double prime to be 0. When x is equal to -2, we have f double prime that is greater than 0. So that is the point of inflection. So that is the point of inflection. So that's it for question 8. And then now we move on to question 9. And this question is about vector. So about vector. So now we have a coordinate that is the origin. Okay, that is A, and then that is B. We have two vector. So how can we find AB? So now we want to find AB. So from A to B, so that is a vector from A to B. To find AB means that we have to work backwards. So this is from A to O and then O to B, right? So we have A, O, and then plus OB. So it means that OB minus OA, right? So these two are equal. And we also have learned that about the equation of straight line. Okay, that is x, and then that is y, and we have a straight line. It's like this. That is called y is equal to mx plus c. We know that the slope means m, and the y-intercept means c. That is the origin. And from these two diagrams, we can learn that. So that is the point-slope form. Another one is the vector form. Okay, how about when we talk about gradient? So what we are talking about in the vector. So we're talking about the vector are the same. Direction, but different in magnitude. Different magnitude. So that is we call it t, and direction times the scalar. This is a scalar t. And for the y-intercept, it means what we mean in the vector form. It means the starting point, right? So we call this starting point as OC, vector OC. So all this thing has been clear. So now we can move on to the question. So now showing how to show that AB is equal to 6, 8, -5. So that is a vector form. And we have learned that for AB. will be equal to OB minus OA. And this has been given, the coordinates has been given. So OB will be just equal to 2, -4, -4. So that is the XYZ direction. Okay, and then minus OA. So what is OA? O is given as -4, -12, 1. So that is X, that is Y, that is Z. Okay, after subtraction, we find that AB will be equal to 6, 8, and then 5. So that's it for part A. For part B, the line L passed through A and B. So now we have to deal with a 3D diagram. Okay, now I draw the 3D coordinates, and I call this one as X, this one as Y, this one as Z, and then we have OA, and then OB, and then the line pass through A and B. The line pass through A and B. Yep. So that is L. This point is A, that is O, and the other point is B. Right? So far so good. Okay, that's a factor. That's a factor. Okay. And then we have to find the vector's equation for L. So I call this one as the direction of the line, and then that is L. So we have this one called R log, this one just called R1. Okay, for simplicity. So now I specify that OA will be equal to R log, and then OB will be equal to R1. Right? So for the part B1 is that R log plus D will be equal to R1. Right? So from OA and then A to B, right? So will be equal to OB. So that's it. So and then D will be just equal to R1 minus R log, right? And this one is just equal to the slope, the M, right? So L will be just equal to R, and R will be equal to R log plus the direction, and then plus the scalar, multiplied by the scalar, sorry. So that is just the form of Y is equal to that is C, sorry, that is C plus that is X, that is M, right? And the T will be a real number. So from this one, we know that the starting point is from O to A, OA, and the direction is AB. So we can think about it just like a Ponsonby form. So we can do this question with ease. Yeah. So that is R is just A plus TD, right? So later we move on from vector, we can deal with tensor with this basic knowledge. So why we have to deal with tensor? Because we can deal with their theory of relativity. So that is the basics. When you know the vector, you can know tensor. When you know tensor, you can know theory of relativity. And then, so what is R? We have to find R. So R will be just equal to A plus TD, right? So that is OA plus T, and then AB is the direction, TD. So we have -4, -12, 1, and then 6, 8, 5. So that will just equal to -4 plus 6t, -12 plus 8t, and then 1, sorry, it should be 1, minus 5t. So that is for part B1. And then now we move on to part B2. So that's part B1, yeah. Then part B2. So we have a point C. This line on L. So we have a point C. This line on L. So I specify it as here. So because it's in the equation, so we can just substitute in it. So we just put C into L. So we can find the value in it. So -4 plus 6t is equal to k, -12 plus 8t, which is equal to 12, and then 1 minus 5t, that is equal to -k. So this is just correspond to x coordinate, that corresponds to y coordinate, that corresponds to z coordinates. So from this we can find the value. So -12 plus 8t, that is equal to 12. So we can find t will be equal to 3. And then we have -4 plus 6 times 3, just plug in a value in it. So we can find k. K will be just equal to 14. So we have just solved part B2. And then now we move on to part C. For part C, we have to find OB.AB. So how can we find OB.AB? We have to deal with the concept that about dot product. So we have the coordinates. So that's called I, that is J, that is K, this K. So what's mean by dot product? So we have I dot I. So they have in the same direction. That is just equal to J dot J. The same direction, dot together, two factors dot together. So that would just equal to 1. So that is a rule. But what happened when I dot J? So I dot J is just equal to J dot K, and also equal to K dot I, because all of them are perpendicular to each other, so they are orthogonal. Will be equal to 0. So now we know the concept, so we can now dot it together, dot them together. So we have OB dot AB. So what is OB? OB just to -4, -4, and then dot together, that is 6, 8, -5. So we dot these two vectors together, we can find 12 I dot I minus 32 j dot j, and then plus 20 k dot k, and then we have something that is I dot j plus j dot k plus k dot I, that is just equal to 0. So that is I. So this part is just equal to 0. So we can find it to be 12 minus 32 plus 20. Finally, we have 0. So what does it mean? What does it mean? It means that we have two vector dot together. So we know the vector form of the dot product will be just equal to these two magnitude times together, and then cosine theta, and theta is the vector, the angle between these two vectors. So it means that theta will be just equal to 90, because we know that from the cosine curve, okay, so that is 1, that is -1, that is 0, and then this is 90 degrees. So when it's 90 degrees, the cosine theta will be just equal to 0. So that's theta, that is 180, and then that is 270, that is 360, right? So that's why it is equal to 90. And then we have just find OB dot OA, right? This is equal to 0, and the angle will be just, that is part 2, right? So angle OBA will be just equal to 90. And then now we move on to part D. So what is part D? It's asking about the area of the triangle OCD. So how to find the area of the triangle? So we have to make use of the cross product this time. So we have two vectors that cross together. So that is A, another one is B. They're making an angle theta. When they cross together, it means that the angle is from A to B, and then we can have a perpendicular, perpendicular vector that is called A cross B, right? And these two vectors can be translated to here, that is B, that is A. So we can have to find this area. So when the product cross together, the vector cross together, so we can find the area of that. So that is A cross B. So the area will be just equal to A cross B, right? But we want to find the triangle. So it means that we just have to find half of this. Just find half of this, right? So the area of the triangle is just half of this cross product. I want to elaborate more about the product. Is you can think about it just a thumb. So you curve your you curve your thumb, and when you curve the thumb, you have a vector. This pointing upward, so this is called A cross B. Yep. So now we have OC. So we can find OC. OC will be just equal to 14. 12 negative 14. We'll find it previously. And then OD will be just equal to 8, 4, negative 9. Right, that is given. And we can draw the graph. So the graph will be look like this. And we have the vector that is OA and this pointing to OB, and then we have the vector that is OD is here. That's the another one C, OC, right? And then we'll find that the OB have to be perpendicular to BC, right? We'll find this property from here, OB dot AB, because AB has to be parallel to BC. So we know that C, okay, I just write in here. Oh, maybe just here. C line is on L. So we have AB that is parallel to BC and also parallel to CD. And we know that OB perpendicular to AB. So we can have OB that is perpendicular to BC. And then we have OB that is perpendicular to CD. And we also know that CD is just equal to CO plus OD. So we have OD minus OC, right? So and that is what we can find. And this kind of property of the writing of the graph, we know that the coordinate is just a position factor. So I want to give you much more the background of the vector. So what does vector mean in here? So in 19, in vector, what does it mean? It means one who carries. So you have to carry something. So you can carry direction, you can carry magnitude. Okay, so that is the knowledge you can have. And about the area, so we know that the area is just half of OB cross CD, right? So OB cross CD, that is what we want to find. And how can we find these two values? So we have to find CD first, and CD just means OD minus OC, so it means that 8 minus 14, and then 4 minus 12, and then negative 9 plus 14. So we find it to be negative 6, negative 8, and then 5 for the CD. And for the magnitude of this, so for the magnitude of this, OB will be just equal to 2 square plus negative 4 square, and then plus negative 4 square, and then square root it. That is just equal to square root of 36. That is 6. And then CD that is negative 6 squared plus negative x squared, and then plus 5 squared, and then we will get it to be square root of 125, right? Okay, enlarge it. Okay, so now we have half of the OB plus OD, that is equal to half of OB times OD and the sine theta, right? So we can find it from the booklet. The OB times OD sine theta. So about OB cross OD, they're perpendicular to each other, right? OB cross the OD. So it just be equal to half 6 and then 1 to 5 square root it, and then it will be equal to 6 and then 5 square root of 5, and then half of that would be just equal to 30 square root 5 over 2. That is just equal to 15 square root 5. So that is the answer for this question. So OB cross the OD. So CD. Okay, I write it wrongly. It should be CD. It should be CD. So you mix an angle that is 90 degrees to each other. Yeah, that's okay. But we can find another approach to deal with this question. Another approach to deal with this question, because we have, so that is the first approach. So we have a big triangle and then minus a smaller triangle, and this is O, that is B, that is C, that is O, that is B, that should be, let me see, that should be D. Yeah. So because we want to find this area, so what we need to do is just to minus this triangle area, so we can find the black one. So that is, you have to find OB cross BC, and then minus half OB cross BC. After finding all this magnitude, you can find the answer. And the second approach is that because we know the cosine square of the angle that is ODC plus the sine square of the angle ODC, that is an identity which is equal to 1. So, and then now we want to find OD, that is equal to 161 square root it, and then CD that is square root 1 to 5, and then OC, that is 556. After all this value, we can find the cosine ODC, which is just OD dot OC. DC should be DC. OD dot DC. Under the magnitude of these two, so we can find ODC. After that, we can find this value, that is sine ODC, and then we know the area, that is just half OD ZD sine angle ODC. So what I'm not finding is that we have the triangle, right? So that is D, that is C, that is O. So I want to find this area. So after finding these two lengths, and I know this angle, so I can make use of this property of this the two lengths multiplied together times the sine of the theta of this. I can find the area. So that is these two approaches. So we have to altogether we have three approaches to do this part C. Part D should be part D. So that is for question 9, a very tough question. And then now we can move on to question 10. So this question about geometric sequence. So how can we do this geometric sequence? Geometric sequence. So firstly, we have to know the formula. So that is the UN is equal to U1 times Rn minus 1. So U is the term, N is the number of term. So for U2, which is a U1 R2 minus 1, that is U1 times R, right? So we can find R, that is equal to U2 over U1, right? That's easy. So for part A, how can we do it? Is that R is just equal to U2 over U1, and then U2 is given, right? U1 is also given. So that is 12 sine square theta over 18. So that is just equal to 2 over 3 sine square theta. That is for part A1. And then part A2 is to find a possible value of R. So to find the possible values, we have to find the boundedness of the sine square theta, because we know it's bounded by 0 and 1. So we multiply both sides by 2 over 3. And then that is R. So we know that R is bounded by 0 and 2 over 3. So that is for part A2. And then we move on to part B. So part B is to find, to show the sum of this infinite series sequence that is equal to this value. So we have to find what is Sn, the sum of all the sequence, that is just equal to U1 times 1 minus Rn, and then times over 1 minus R. But Sn approaching to infinity, so infinite sequence, right? So it means that Rn, that is also approaches to 0, because we know that R that is more than 1, right? From this value, right? We know that. So it means that okay, So it means that 1 minus our n, so that is approaches to 1, right? So we can have the s infinity, that is equal to u1 over 1 minus r. So that is the formula, and we know u and also we know r, so we just plug in the value, so we can find it to be 1, okay, minus 2 over 3 and sine square theta, and then we can simplify this one, so that is just 3 minus 2 sine square theta, and then times, and then over 3, right? So over 3 means just times 3 over the fraction of the fraction. This is the integer. And then that is 54. And from this part we have 1 plus 2 times 1 minus sine square theta. Or okay, I have another option to do this question. So I have 2 plus 1 minus 2 sine square theta. So what I'm doing is using the double angle formula. So what I'm now doing is that we know that cosine 2 theta, that is equal to cosine square theta minus sine square theta, right? And then we know the cosine square theta is just 1 minus sine square theta minus sine square theta now. So we have 1 minus 2 sine square theta. So exactly this value. And okay, it also means that it is equal to cosine theta minus 1 minus cosine square theta, right? So it means that we have 2 cosine square theta minus 1. So for completeness, I also deal with this formula. So now we have 54 over 2 plus cosine 2 theta, right? I think that's it. That's it for this part. So exactly this value. Yeah. So now we do part C. For part C is to find the values of theta which gives the greatest value of the sum. So how to find the greatest value of the sum? It means that we now having the s theta is equal to this value. So this to be maximum, so this value have to be variable. We know that that's constant. We know that that is constant, and that is the only variable. And how it can vary, because we know the cosine curve is that it can be equal to that can be equal to 1 to negative 1. It's vary from 1 to negative 1. So for the greatest value of that, so it has to be the least value. So it has to be equal to negative 1. So now we have cosine 2 theta that is equal to negative 1. So it means that 2 theta, so that is pi. We know that is pi. And that is a sinusoidal pattern, is a repeated pattern. So that is 2 pi. And this one is just 4 pi, right? So it means that this one is 3 pi. So here we have pi, 3 pi, etc. So we have theta will be just equal to pi over 2, and then 3 pi over 2, etc. Yeah, etc. But the question specified that theta cannot be greater than 2 pi. So for this one will be, for the next one will be 5 pi over 2, that is greater than 2 pi. That's greater than 4 pi. So all this has to be rejected, right? So that's it. And I can find another approach to do this question. Another approach is that, so for the greatest value, of the sum, so we can do the differentiation. So differentiate as the infinite series with respect to thetas, because it's changed with theta. And then we have d theta of the function, that is 54 over 2 plus cosine 2 theta. So after differentiating it, we can have negative 54 and then 2 plus cosine 2 theta, and then negative, that should be negative 2. And then using the chain rule, we can have sine negative sine 2 theta and then times 2, which is equal to 0. So we can have it to be 0 when sine 2 theta is equal to 0. So it means that we have theta, 2 theta, that is equal to 0, pi, 2 pi, 3 pi, because we know that the function will look like this. Then this is pi over 2. Pi over 2, that is 2 pi. That is 5 pi over 2. That is 3 pi, right? So that is theta, that is sine theta, that is 0. So we can have theta, that is pi over 2, and then pi, and then 3 pi over 2, right? Oh, but the question is given that theta cannot be equal to pi, so that is being rejected. This being rejected, so we can only have 0, pi over 2, and then 3 pi over 2. So we can have two approaches to do this, find the greatest value of this function. So that is for section 8 and section B. And if you still have any question, you can comment below, and you can also share this video. You can also comment this video. If you want to have more videos, please subscribe it just to stay tuned of my channel. If you like it, please give me a thumb, right? So that's it for this paper. So this paper is 2018 paper 1, so TZ1. So stay tuned.